Today we're going to learn Unit 2, Lesson 2. This is on linear equations. You should have learned about linear equations in Algebra 1. This is all review. There are three different forms of a linear equation. Slope-intercept form, which is probably the most commonly used, is y equals mx plus b, where m is the slope and b is your y-intercept. Point slope form, that's y minus y1 equals m times x minus x1, where m is your slope and x1, y1 is an ordered pair on the line. A lot of Algebra 1 teachers skip this one because with the use of calculators, this one becomes redundant. But the further you go in your math classes, the more important this one is going to be. We use this one in calculus all the time because it keeps us from having to convert to slope-intercept form when our ordered pair gets to be something that you cannot simplify. So this form should never be skipped. That they're doing you a disservice by skipping this one. So I'm going to concentrate a little bit more on this one so you understand where it's coming from in this lesson to make sure that you can use it later. And then in standard form, ax plus by equals c. This one really is the most useless form of a linear equation. One thing about Desmos though, if you type something in linear form or in this form into Desmos, it makes it very simple because Desmos will graph this. I don't know of any graphing calculator that will do that for you. You have to convert to slope-intercept form before the calculators are going to graph a line. So Desmos does make standard form easier, but the problem with using Desmos with standard form is you don't know how these three forms relate to each other. And that's what we're going to concentrate on in this section. You need to understand where these things come from to help you with where we need to go with this later. In this segment, we're going to talk about how to graph equations that are written in slope-intercept form. And remember, we said slope-intercept form was y equals mx plus b. So if you have something in that form, the number in front of x is your slope and the b value is your y-intercept. So looking at this first example, if I have y equals 2x minus 4, my slope is 2 and my y-intercept is negative 4. So if I were to graph that, I'm going to go to the y-axis on negative 4 and I'm going to make that my y-intercept for my line, and then from that point I'm going to go a slope of 2. Well, if you think about that, the slope of 2 means rise over run, so that would be 2 over 1. So from this ordered pair, I'm going to go up 2, right 1. And I can continue that pattern and do several more points to get a good idea of where my line is going to be. I always use a ruler if I'm graphing these by hand so that I can make sure I get an accurate graph of what I'm looking for. So that equation is y equals 2x minus 4. And if you think about what we talked about earlier with slope, slope is positive, and if you count that slope up 2, right 1, so the slope is 2. The minus 4, it crosses the y-axis at negative 4. So that is a review of slope-intercept form. Let's look at the second one. This one, the slope is negative 1/2, so it's going in the other direction. It should be going up toward the left, and the y-intercept is 2 in that case. So to graph that one, I'm going to go up 2, and then from there I'm going to go up 1, left 2, or I could go from that point down 1, right 2, whatever your preference is. And then I'm going to continue that pattern for several points, and then I'm going to draw my line using a ruler to make it accurate. So that one is y equals negative 1/2 x plus 2. In the next one, this one is actually the parent function of a linear equation. But the parent function, what you need to understand is the number in front of x, again, is your slope. So the slope here is going to be 1, which is 1 over 1 when you're talking about rise over run. And then since there is nothing here, that's understood to have a plus 0. So the parent function here has a slope of 1 and it crosses the y-axis at 0, or the origin. So it crosses the y-axis at the origin, and then from there I go up 1, right 1. And I continue that pattern in both directions to get my parent function of a linear equation. So here is my parent function. I'll label that here. That's y equals x. And then this one is very similar. It's y equals negative x. Well, the negative here means it's got a negative 1 in front, so the slope of that one is a negative 1. There is no y-intercept, so that's understood to be 0. So again, that one crosses at 0, or the origin. And then from here, I can go up 1, left 1, or I could go down 1, right 1, to get my y equals negative x line. Now, if you think about that, when we did parent functions, didn't we say that if you put a negative in front of the x, then it's going to be a reflection across the x-axis? Well, if you think about this, if I flip that across the x-axis, isn't this what I'm going to get? So we have the parent function with its reflection across the x-axis there for the y equals negative x. So y equals x and y equals negative x are going to be reflections across the x-axis, and we'll talk more about that in the next section. In this segment, I want to talk to you about how slope-intercept form and point slope form and standard form all represent the same line on the graph. I just want to make the connections between those three things. This is the same example we did earlier, y equals 2x minus 4. The y-intercept is at negative 4, the slope is 2 over 1, so we have that same line there that we had graphed earlier. Now, what I want to do is I want to talk about how that relates to point slope form first, okay? We learned earlier that point slope form is y minus y1 equals m times x minus x1. And we also learned that m is your slope. So if I'm going to convert this to point slope form, and I can do this for any point on that line. So I'm going to just pick one of the points and plug it in here to see if in fact I would get the same slope-intercept form with any of the points on that line to show you that connection. So with this, I know that m is my slope. So I'm going to replace m with the slope of the line, 2. And then I also learned that the x1, y1 represents an ordered pair on my graph. So I'm just going to randomly pick an ordered pair that I came up with on this graph. And I'm just going to pick this one right here. Let's do this one. That is the point 3, 2. Okay? So what I'm going to do is I'm going to take that ordered pair and I'm going to plug that ordered pair in for my x1, y1. Okay? So in this equation, it says x minus x1. Well, looking at that point, that was 3, 2. Okay, so x minus x1 is 3, and y minus y1 was 2. Okay, now this is point slope form of that line at the point 3, 2. Okay, now if I were to ask you to convert this to slope-intercept form, let's see what we would get. If we do the math, we can distribute the 2. So we've got y minus 2 equals 2x minus 6. Then in order to get this in slope-intercept form, y has to be by itself. So if I add the 2 over to both sides, I'm going to have y equals 2x. Negative 6 plus 2 is minus 4. Now look at what happens. y equals 2x minus 4. We get the same slope-intercept form when we choose the point 3, 2. Okay, let's think about that. What if, instead of choosing the point 3, 2, let's say we choose the point -1, -6. I'm going to do the same thing. Y minus y1 equals m times x minus x1. This time I'm going to plug -1, -6 in for x1, y1. So I have y minus -6 equals m, well the slope of that line is 2, times x minus, in this case, x1 is -1. So if I simplify that, I have y plus 6 equals 2 times x plus 1. And then if I want to convert this to slope-intercept form, then I'm going to get y by itself. I would distribute the 2. So y plus 6 equals 2x plus 2. Then if I subtract the 6 over, y equals 2x minus 4. So look what happens. This same thing, in fact, is going to happen no matter what point or what ordered pair I pick to plug in for my x1, y1. That's what makes it a linear equation. No matter what point you pick, when you convert it to slope-intercept form, you are going to get the same y equals mx plus b form. So that's how this function relates to the point slope formula. Next, I want to talk about how that equation is connected to the standard form equation. If I want to convert this to standard form, the standard form of the equation, we learned earlier that standard form is ax plus by equals c. Okay, now with Desmos, there's really probably not going to be a reason to convert standard form to slope-intercept anymore because the calculator does it for us, okay? But you still need to understand the relationship between the two as we go further with our knowledge of linear functions. So basically what we're going to do here is to get this into standard form, we have to get the x's and y's on the left and then a number on the right. So all the variables have to be on the left, and you're left with a number on the right side. And in order for it to be in standard form, your x has to be in front. Okay, so if I'm going to do that with this, to get this x in front of the y, wouldn't I subtract 2x? So if I subtract the 2x to the other side, I would end up with -2x plus y equals -4. And then one of the special things about standard form is that none of your coefficients or none of your a, b, c values are allowed to be fractions. And the a in front cannot be a negative. So if we have a negative in front, we have to multiply everything by a negative to get rid of it. So we're going to multiply everything by -1. So that would be a 2x minus y equals 4. You should have had that in your Algebra 1 course. If you didn't, no big deal. This is not a form that we use very often, but occasionally you might have to convert it to something that's graphable. If you don't have Desmos, to convert that to something that's graphable, I would get y by itself. I would end up with this, and I'd be able to graph it using the slope and y-intercept. Okay, so all three of these forms are interchangeable. We can go from one to the other, and they should always give us the same form of the slope-intercept form, no matter where we start. In this example, we're going to go backwards. I've given you a linear equation graphed, and I want you to find the slope-intercept form of what we have graphed. Now, that's pretty simple. You should have learned it in Algebra 1, but we know that if slope-intercept form is y equals mx plus b, then b is the y-intercept and m is the slope. So in order to write this equation in slope-intercept form, all I have to do is figure out what the slope is and what the y-intercept is to have my slope-intercept form. So if I look at this, the first thing I'm going to do is find the y-intercept. Now looking at this, my y-intercept is 3. So I know B is 3. Then I have to find my slope. Well, if that's a corner point, then I'm going to find another corner point. Looks like this right here is a corner point. So if I count my slope, I go up 2, left 3. So my slope is -2/3. So my slope-intercept form of that line that I had is y equals -2/3 x plus 3. Now, what if they asked me to convert that to standard form? Well, converting that to standard form, I have to remember the x to the front. So if I move that x to the front, that's going to be a +2/3 x because I'm moving it to the other side, plus y equals 3. And then remember, none of my coefficients or none of the ABC values are allowed to be fractions. So in order to get rid of this fraction, I'm going to multiply everything by the denominator so I don't change the value of my equation. So 3 times 2/3 is 2x. 3 times y is 3y. 3 times 3 is 9. There is my standard form of the equation. Now, if they were to ask me to get point slope form, I could have an infinite number of point slope form equations for this one because remember, you can pick any point on the line and plug it into the slope or the point slope form. So by picking any of these points, I could get a point slope formula. So if I ask for point slope form, I'm going to tend to give you a point to choose from. That way I don't have an infinite number of answers that I'm checking for. It makes it very difficult for me to check for those if I don't give you a specific ordered pair to work with. The directions here are asking me to find slope-intercept, point slope, and standard form given the 2 ordered pairs. So I have 2 ordered pairs here and I want to find all of those equations. Well, I could graph them and I could see where the graph goes and try to do it that way. Or I could just use my knowledge of the slope formula and then try to plug in the information to get my ordered or my standard and slope-intercept and point slope form. So let's find the slope first using the slope formula from the last section. So if I do that, my slope would be 7 minus 6 or 1 over 5 minus 3, 2. So my slope is 1/2. Then I know that point slope is y minus y1 equals m times x minus x1. If I have my slope and at least one point, I can always plug into point slope form to find the equation of the line. So if I do that, and at this point you can pick either one of these ordered pairs. It doesn't matter a bit. You can pick either one of them, plug that point, and I'm just going to choose the first one. You can plug that point in for x1, y1. We have the slope to plug in, and then that form I can convert to the other 2 forms. So my point slope form, if I plug 3, 6 in, I would have y minus 6 equals, slope is 1/2 times x minus 3. And that is point slope form. Now, keep in mind, I could have plugged in 5, 7. If I would have y minus 7 equals 1/2 times x minus 5. And then when I convert, I will get the exact same thing for slope-intercept form. If you don't believe me, you can try it, but I'm just going to convert this to slope-intercept form now. In order to get it into slope-intercept form, I have to get y by itself. To get y by itself, I'm going to distribute the 1/2. So I've got y minus 6 equals 1/2 x minus 3/2. And then I'm going to add 6 to the other side. So y equals 1/2 x, and then -3/2 plus 6. That would be a positive 9/2 or 4 1/2. So this is my slope-intercept form. And then to convert that to standard form, I remember move the x to the other side. So that would be negative 1/2 x plus y equals 9/2. And then remember, I'm not allowed to have any fractions, and I can't have a negative in front. So with this one, I'm going to be allowed to eliminate the negative and the fractions all at once. I'm going to not only multiply by a negative, I'm going to multiply by a -2 to get rid of the negative and the fraction at the same time. So -2 times -1/2 is 1, so that's just x. -2 times y is -2y. And that equals, and I have to do it over here too, the -2. -2 times 9/2 will be -9. And that is the standard form of my equation. So I have two ordered pairs. To find the slope, I do the slope formula. Then I can plug one of the ordered pairs and the slope in for point slope and convert to get all the other equations. Now, if they were to ask me to graph this one, looking at the slope-intercept form, I would be able to graph it by hand, but I wouldn't be able to make sure that I get it completely accurate without a computer or a calculator. Because when we graph fractions, remember we're in between our corner points. So it might not be real accurate if we graph it. We can get a good understanding about what the graph would look like, where it would cross the y-axis, and how steep the slope would be and what direction it's going. But other than that, we're not going to be able to graph it correctly or exact by hand. Only on a computer could we do that. This example is a little different. If I were to ask you to find the slope-intercept form of this equation, there's a little problem that we have. If you look at this one, the y-intercept is not on a corner point. So we can't identify the y-intercept just by looking at this one. So it makes this one a little bit more difficult to find the equations for. So we're going to find all three. We're going to find slope-intercept, point slope, and standard form of this equation using some information that we have. Well, anytime I'm given a graph and a graph of a line, the first thing I'm always going to do is I'm going to find the slope, because that's the easiest thing to do at first. So I'm going to find two corner points and I'm going to find the slope. So let's see, 4, 0 is a corner point and 1, 1 looks like a corner point. So if I'm finding the slope of that equation, I'm going to start at the bottom. I go up 1 and I go left 3. So my slope there is -1/3. So my slope is -1/3. Then if I want to find the slope-intercept form of that equation, I could find it real simply by using one of those points, putting it in point-slope form, and then converting it to slope-intercept form. Really, that's the only way to be able to find slope-intercept form here. Well, it's not the only way. I'll show you two ways to do it. It's probably the easiest way, and I'll show you why in just a minute. So what I'm going to do is I'm going to write the formula for point-slope form. Y minus y1 equals m times x minus x1. And then I'm going to pick a point. I'm going to use 1, 1, because 1, 1 is always really easy to plug in. So I'm going to use the slope, -1/3, and the point, 1, 1. And I'm going to plug into point slope form. So if I do that, I have y minus y1 is 1 equals m, which is -1/3, times x minus x1 is 1. And then I'm going to distribute. So I've got y minus 1 equals -1/3 x plus 1/3. Then if I add the 1, I have y equals -1/3 x plus 4/3. And you can use your calculator or Desmos to do the fractions. You don't have to be able to do that in your head. And so looking at this, my y equals -1/3 x plus 4/3 is my slope-intercept form. And let's just look at that. 4/3. Wouldn't that be 1 1/3? So our y-intercept is at 1 1/3. Well, that looks about right. That looks like it's about 1/3 between 1 and 2. And my slope is negative 1/3, which we found from the graph. So there is my slope-intercept form of a line that doesn't go through a corner point for my y-intercept. Now, I could also then convert this to standard form if I wanted to by taking the negative 1/3 to the other side and then multiplying by everything by 3. So I would have x plus 3y equals 4 for my standard form. But honestly, in Algebra 2, we really don't do this much. I probably won't do any more of those at this point. Now, let's do this one another way. What if I'm going through, I'm taking my test, and I have forgotten what point-slope form is. I've forgotten what the formula is. Well, no big deal. This is how your Algebra 1 teacher probably taught you how to do this. It still works, but I don't want to skip point-slope form because you will use that so much later. It's a lot easier later for you if you have been exposed to that already. So that's why I wanted to make sure I did that. But let's suppose you forgot point-slope form. You forgot it, don't remember it. But you do know slope-intercept form is y equals mx plus b. Well, we can still do this equation. We don't know what b is, okay? But we do know m is negative 1/3. So here's what I'm going to do in this case. I'm going to put negative 1/3 in for m. And now I need to figure out what my y-intercept is. Now, we never look at it and try to estimate. Do not estimate. You're going to get it wrong most of the time if you try to do that. You have to have exact answers. Well, if you think about it, if I have x and I have y, when we did xy charts when we were doing parent functions, wasn't the x and the y in the equation representative of an ordered pair on the graph? Okay? Well, I could take an ordered pair on the graph. In this case, I'm going to take 1, 1. And I can plug 1, 1 in for x and y. So in for x, I would put 1. And in for y, I would put 1. Or, I don't know, maybe you prefer this point right here. Negative 2, 2. Well, in that case, I would put negative 2 in for x and 2 in for y. You see what I'm doing here? Any point on the line could be your x and y values. Okay, so let's just use this one for argument's sake to see if we get the same thing. 2 goes in for y. Negative 2 goes in for x. And by solving this, we can come up with what b equals. Negative 1/3 times 2 is 2/3. And then if I subtract 2/3 from 2, I will get 4/3. So my equation is y equals negative 1/3 x plus 4/3. And that is probably how you learned it in Algebra 1. Did we get the same thing? Doing it 2 different ways? Yes, we did. It doesn't matter at all which way you do it. We're looking for the right answer. So whatever is easiest for you is how you want to do that problem. But what you need to understand is Desmos won't do that for you. You have to have that knowledge, which is why we went through all this. We have 2 special linear equations that I want to talk to you about. One of them is a function, the other is not, and you'll understand why in a few minutes. If I were to give you 2 ordered pairs and ask you to find the equation of the line. So if we have 2 ordered pairs, remember the first thing we're always going to do is find the slope. So if I do that, negative 2 minus negative 2. Well, negative 2 minus negative 2. Well, that's negative 2 plus 2. That is 0. Over negative 6 minus 3 is negative 9. Well, we talked about this when we were dealing with slope. If you have 0 on top, 0 divided by anything is 0. Now, automatically, when you see a slope of 0, your brain should be telling you it's a special type. Which type was it? Is it horizontal or is it vertical? A horizontal line has a slope of 0. So to see that the slope here is 0, let's graph it to see if it actually is a horizontal line. So if I graph that, 3, -2, -6, -2, and then I draw my line, we can see pretty quickly that that is a horizontal line. So now, how are we going to express the equation for that horizontal line? Because this is very important that you understand this. If we're trying to talk about slope-intercept form, y equals mx plus b, well, if you think about that, that horizontal line crosses the y-axis at -2. So b would be -2. Our slope is 0, we said. So there's my equation for that horizontal line. Well, you know from algebra that if you multiply anything by 0, multiplicative property of 0 tells us that is 0. So what we have here is y equals 0 minus 2, or -2. So my x value drops out when it's a horizontal line. In fact, that happens for every single horizontal line. So if my equation here is y equals -2, we can make a connection with that. Let's think about that. If y equals -2, well, this ordered pair is -6, -2. This ordered pair is -5, -2, -4, -2, -3, -2, -2, -2, -1, -2. I could go all the way across this horizontal line and every single y value is -2. That's why my equation is y equals -2. Every single y is equal to -2. So my equation for a horizontal line will always be y equals, and it will be y equals the y value of the ordered pairs. Look at the y value of the ordered pairs here. So if you are given two ordered pairs that have the same y value, and you figure out that the slope is 0, you can stop there. There's no need to graph it. There's no need to do any of this. You know it's going to be y equals whatever the y coordinate is. Okay, so that's a shortcut for your horizontal lines. So let's talk about what happens with the other special case. I have two more ordered pairs, and let's see what happens with these ordered pairs when we try to graph them and find slope-intercept form. If I find the slope, which is always what I'm going to do when I have two ordered pairs, I have -5 minus 2, which is -7, and 5 minus 5 is 0. Now remember, when we talked about slope, can we divide by 0? Any number divided by 0 is going to be, what did we say? We said it was going to be undefined or have no slope. Okay, so think about that. If it has no slope, what kind of a line did we say it was? Hopefully you're saying we said it was going to be a vertical line. Now, let's look at this and see if in fact it's vertical. 5, 2, and 5, -5. Well, if I graph that, you can see pretty simply it is vertical. It goes through both of those. Oops, it's a vertical line. I got off a little bit, but it's very close. All right, so there's my vertical line. So if it's vertical, let's think about how to put that in slope-intercept form. Well, we've got y equals mx plus b. Well, there's a problem. If my slope is undefined, and I put undefined in here, and then if I try to plug in my b value, well, okay, there's a problem there too. Where does that cross the y-axis? Because that's what our b value is. Does it cross the y-axis? It doesn't. So we can't plug in for the slope or b. There's no way to do that because b doesn't exist and m, there is no slope. It's undefined. All right? So we need to think about the knowledge that we said with the horizontal lines. We said that in a horizontal line, the equation was y equals whatever the y value was of the ordered pairs. Look at your x values of your ordered pairs in your two coordinates here. Okay? My x values are the same. if my x values are the same, well, automatically it's going to be a vertical line. Now, think about that when we talked about functions, okay? When we talked about functions, didn't we say that if a vertical line hits more than one point, it's not a function? This, in fact, is the only linear equation that is not a function because it's a vertical line. And in a vertical line, since the x value is the same in every single ordered pair, the equation of a vertical line will always be x equals whatever that x value is. And we can do the same thing we did with that horizontal line. Look at every ordered pair here. This one is 5, 3, 5, 2, 5, 1, 5, 0, 5, negative 1, 5, negative 2, 5, negative 3, and so on. I could go through that entire line and every single x value would be 5. So the equation of that line is x equals 5. Because no matter what I give you, x will be equal to 5 for all of them. There's only one more thing I want to talk to you in this section about, and that is finding the x and y intercepts. The x and y intercepts are where the graph crosses the x and y axis. So if you look at this, for this line right here, now we could write the equation of the line. Y equals, let's see, my slope is 1, 2, 3 over negative 2. So negative 3 halves x plus 3. That's the equation of the line. We've learned that. We could convert that to slope-intercept form, or that is slope-intercept. We could convert that to standard form. We could also find a point-slope form for that. But what we're concentrating on now is where are the x and y intercepts? Okay, the x-intercept is the point where it crosses the x-axis. So that crosses the x-axis at 2. So the x-intercept is at 2. The y-intercept is where it crosses the y-axis. So my y-intercept there is at 3. Now, you could say that the x-intercept is the point 2, 0, and you could say that the y-intercept is the point 0, 3. It doesn't matter really how you express it. You could do it either way. So if you're given a graph, you're just going to simply look at where it crosses the x-axis, that's the x-intercept, and where it crosses the y-axis, that's the y-intercept. Okay, now, what if we're given a slope-intercept form? Well, if I have something like that, what I'm going to do is I'm going to graph that and see where it crosses the x and y axis. So to graph that, my y-intercept is 4. My slope is 2. So that means from this point I could go up 2, right 1, or I could go down 2, left 1. And so there's a good idea of what my line is doing. My x-intercept, it looks like it crosses at negative 2. So my x-intercept is negative 2. My y-intercept is 4. So I could say my x-intercept is negative 2, 0, and my y-intercept is 0, 4, or I could just say the x-intercept equals negative 2, and the y-intercept equals 4. I could do it either way. Now, here's something important you need to make a connection about. The x-intercept and the y-intercept, if this is the x-intercept, that's at negative 2, 0, and the y-intercept is at 0, 4. Well, if we are at an intercept on our graph, then either x or y, the x or y coordinate, is going to be 0. Look at my x-intercept. In the x-intercept, the y coordinate is 0. In my y-intercept, the x coordinate is 0. So another way I could do this is I could do an XY chart, and I could plug in 0 for x, and I could plug in 0 for y, and solve. So you don't necessarily need a graph to be able to do this. So if I plug 0 in for x, well, that's going to give me 2 times 0 is 0, plus 4 is 4. My y-intercept is 4, which we knew that based on the slope-intercept form. Or if I plug 0 in for y, 0 equals 2x plus 4, and then I just solve that equation, x will be equal to negative 2. So there's how I can do it algebraically. The good news is, if you have something in standard form, it makes finding the x and y intercept extremely easy because we don't have to deal with any kind of graph at all. If we do an XY chart and we know that if we plug 0 in for x, we get the y-intercept, and if we plug 0 in for y, we get the x-intercept. This math is really simple. If I plug 0 in for x, well, that goes away, and I have 2y equals 6, well, y would be 3. The y-intercept is 3. If I plug 0 in for y, well, that's gone. 3x equals 6. Well, 6 divided by 3 is 2. The x-intercept is 2. And it works the same way even if you end up with some fractions. You'll have fraction intercepts sometime, but that's real simple to plug in. So algebraically is probably the easiest way to do these because you don't want to have to graph if you don't have to. It just makes life a little bit more difficult because it's adding another step. Whereas if you know your algebra and if you know that in an intercept, the x either has to be 0 or the y has to be 0. So in the x-intercept, the y has to be 0. For the y-intercept, the x has to be 0. If you know that, it will make life a lot easier. It will make it a lot easier to find your intercepts.